Hi, everyone. My name is Francisco Castillo. I am a data scientist here at Arize. And with me, I have Jeff Boudier. He works at Hugging Face. And we are extremely lucky to have him with us. He's going to answer some interesting questions that we have thought for him. But we want to keep this light. And if you have questions for him, please drop them in the chat and we'll address them in the Q&A section. We have people helping with us, so they might answer also during the panel. And if any of your questions don't get answered by any reason, we'll make sure that they get answered in the Arize community. So feel free to drop there as well. So Jeff, I'm a fan of Hugging Face, so I cannot tell you how happy I am that I'm talking to a person one-on-one. So tell us a little bit about yourself, if you don't mind giving an introduction to everybody here.
Of course. Well, thank you so much. And thanks for inviting me to this conversation. So I'm Jeff Boudier. I lead the product team at Hugging Face. And I guess you were asking about my personal background. I'm probably the least interesting person at Hugging Face. You know, we have these amazing scientists and leaders in the fields and machine learning engineers that do amazing thing. My role has been for the past couple decades about taking things that are very complex and intimidating for people to do and sort of break them down and make them accessible through products and things people can use and can buy. And so, you know, our mission as a company is to democratize good machine learning. And by good, we mean built from ethics first principles, and we mean state of the art. And we do this through our open science contributions. You may have heard of Distilbert, Big Science. We do this through our open source contributions. And we do this through our products and services. And that's the part that I focus on. How do we accelerate the adoption of transformer models, of machine learning, good machine learning within companies?
I gotta say, the first time I went into the page and the first time I learned about Hugging Face, I was very impressed by the mission of democratizing AI. Now, for me, that kind of resonated a lot. And can you develop a little bit more what that means a little bit more in practice?
Yeah, it has many aspects. One is the accessibility. One of the things that the AI community really loves about Hugging Face is that if there is a new exciting paper that comes out of the science, it gets available as something that people can use within their own environment, their own code, their own notebook, within typically a few weeks. And so it is making those latest innovations that are coming from the global AI community accessible, easy to use by the global community. So accessibility is one important thing. Another important thing is that everything that we do at Hugging Face is community driven. And so that means that we represent the sum contribution of the global community, providing those models, implementations to our open source libraries, those open source checkpoints through the Hugging Face Hub. And so that's a very important part of the democratization, because we want everybody to be able to use and leverage those technologies, not just the largest tech companies in the world. And so that means making those algorithms, those technologies easy to use by anyone, relevant whichever context you're in, which for natural language processing, that means whichever language you're speaking. So it's very important for us that everybody in the world can benefit from those technologies. There's another aspect too to democratization, which is to make things cheaper and more efficient. And so efficiency is a very important topic for us. It's particularly important because those technologies, those transformer models, are extremely large. And so they consume a lot of resources, memory, bandwidth, energy, to train those supersized machine learning models, which then use a lot of energy, compute resources in order to be deployed at scale. So that's why for us, efficiency has always been like a very important topic from a science perspective to an open source to a production perspective. The Distilbert model is a great example of that, right? So you take the seminal BERT encoder model that was developed by Google, and then through a process of distillation, you make it 60% faster and 40% smaller, while retaining, I think, more than 98% of its original accuracy, right? And so it's through techniques like this, distillation, other techniques like quantization, like pruning, that we're able to offer these amazing technologies in a way that can be run efficiently on commodity hardware or on any hardware.
I gotta say, like when you explain all of that, it's very interesting. But I also think it's very easy to put those like very noble goals, and I don't think it's easy at all to achieve them. And from my personal experience, when I was learning, when I started my journey on AI, I was very interested on unstructured data, image processing, and language models. And I kind of dropped my dream, if you will. I said, okay, this is very expensive. I cannot do anything feasible. I cannot experiment with this. And then I found out about Hugging Face. I said, wait, I can actually use this model that these huge companies trained, and I can actually run experiments with them and be actually useful. So in that front, I think definitely the goal is achieved. I mean, I'm sure that you have more ambitious goals, but for me, as I was learning not long ago, it definitely played a role. You mentioned also, I noticed that you said the word checkpoint, but I just want to cover, just in case that any of our audience doesn't know what it is. Would you care to maybe do a little demo and say if there, what, you know, in that demo, what a checkpoint is? And I don't know if you have anything that you can show us for people.
Yeah, of course.
Even if you've seen the actual Hugging Face page, I had the experience, and in a year it looks like completely different. It's in a year, I thought I had been sleeping for 10 years, and you guys kept working while I was sleeping. So if you can show us, that would be awesome.
Thank you. Well, yeah, the field is evolving very fast. I mean, it's hard to put this into that perspective, but the Transformers library is only 3 years old, right? And within those 3 years, we went from one model to 50,000 models, and Transformers have sort of changed what's possible to do, not just in the initial field of applications of natural language processing text, but also now, like in every modality of machine learning, from audio processing to computer vision, chemistry, reinforcement learning, you name it. I think it's the first time for the AI field where everybody within the community is actually using a consistent set of architectures and tools to achieve state-of-the-art results, right? If you look back just 2-3 years ago, you had very much distinct disciplines, distinct libraries, sort of distinct tools and architectures to do natural language processing, or to detect faces, images in videos, or to transcribe speech into text. And because transfer learning has changed the field and is now producing the best possible performance across all these modalities, the first time that everybody within the AI community is focused on the same set of tools. And that's what makes Hugging Face as the sort of center of that ecosystem so valuable for the community. So yeah, I promised you a demo. I'm not gonna shy away from that. So you should be able to see my screen. What I'm showing you is the Hugging Face hub, right? So it's what you see when you go to huggingface.co or hf.co, and you click on the models page. This is what data scientists, machine learning engineers all over the world, over 100,000 of them every day, go to find the best possible pre-trained or fine-tuned models to solve the problem that they're trying to solve. And so here you can see there are over 50,000 of them that are ready to be used and accessed in code or here on the page to do any kind of machine learning task. So on the left-hand side, you see some of these tasks. I can expand them and zoom in a little bit. So in computer vision, you can do things like image classification, or you can do object detection. This is a car. This is where the car is in the image. You can do any kind of natural language processing, like classifying text. Is this answer positive or negative? What is this about? Like, what is the intent? Or you can generate text. You can generate text for conversing with your customers through a chatbot. You can summarize a long article into a short paragraph. You can translate text from one language to another. So whichever of those tasks you're trying to use to solve your business problem, we have a great set of models for that. Same is true for audio, text, speech to text, and we have more and more, and that's a recent trend, multimodal sort of experiences where you can go from text to an image, you can go from an image to a text, or make sense of multimodal things together. So yeah, if I select, for instance, question answering and take this first model, every model that is hosted on the Hugging Face Hub will give you all the information that you need as a practitioner to understand how you can use it. So it goes from where this was trained from, what data set is it linked to, which applications like Spaces is it linked to. If you want to see how it works, you can right off the page test it by providing real inputs, like here this long context for which this question is being asked. What name is also used to describe the Amazon rainforest in English? The answer is Amazonia, or the Amazon jungle, taken from the text. So everything here is made very interactive, so that even if you don't have a PhD in machine learning, even if you don't know much about deep learning at all, you can understand how the model can be used, the limitations of the model, which we invite model contributors to provide through the model card that's implemented here and that we're looking at there. So that's models in a nutshell. We also want to make sure that the community can access and contribute back the data sets that they built in order to create those models. And so here, with a similar experience, you can browse through over 5,000 models that have been contributed by the community to build any kind of model, and filter down to the language that you want to focus on, to the task that you want to focus on. And then when you look at the data set, you have all the information you need to actually use it, right? So you see what data is contained within. You can see which papers reference the data sets, which models have been trained on the data sets, what are the ethical considerations and the information that is offered by the contributor through the dataset cards. So here you have sort of a wealth of resources for somebody who wants to solve a business problem, and they can narrow quickly down to the best possible models they can use off the shelf, contributed to by the community. Then the next step after that, and typically data scientists will do that, is take those models and then adapt them to their particular context, their particular data set. And they can do so with our tools like AutoTrain, which is our no-code solution to fine-tune your model with your own data set. You just upload your data set and get state-of-the-art models back that are already fine-tuned, that are already evaluated for metrics, that are already deployed, so you can serve predictions from them. Yeah, as I said, like any of the models that is hosted on the hub can be queried directly on the page through the inference API I demonstrated, and HTTP endpoints to do the same programmatically. Now, I want to maybe one last thing is, so here's my my personal page, and then you can see that as a regular user of Hugging Face, you will be plugged into what's happening in the community, what's happening within your team, your organization that's using Hugging Face to do their machine learning, including what's trending right now. And I mentioned Spaces. Spaces are machine learning applications that are built very easily in a few lines of Python code using Radio or Streamlit, and hosted for you by Hugging Face, so you don't have to worry about DevOps or infrastructure or anything. And so the community regularly puts out some amazing new experiences that really participate to that angle that I was talking about earlier, which is to democratize AI, to make it tangible, interactive, understandable, explainable, right? And so DALL-E Mini right now is an incredibly popular space. You probably saw on Twitter or in news articles some of the creative parts that it generates. What should we ask DALL-E Mini to create in terms of image?
Transformers in the sky. Let's see.
In the sky?
Let's see if there's one flying out there.
I will let it run for a while, and then we'll go back to see.
While we wait in that, as I said, like I used this a lot a while ago, and then I came not long ago to use it again, and the difference in what you've explained to us is incredible. But the one question that I have that I have not yet used Hugging Face for is for production. What trends do you see teams using Hugging Face for production issues in their applications? Where do you think the industry is going, or what are the trends that you can see?
Yeah, so one trend that has been very clear over the past 9 months is the expansion of the applicability of transformer models, models based on attention-based mechanisms, to new sort of use cases. So, you know, I told you all about the natural language processing, which was the initial way through which those models were being used, right? So when you type a query on Google search, it's a BERT-like model that will provide you with semantically correct results. When you type an email in Gmail, it will try to complete your sentences. Again, that's natural language processing powered by transformers. But increasingly, those models are proving very, very useful for other use cases. So, for instance, the transcription of audio, if you use some kind of software that will automatically create captions on top of videos, or that will translate in real time, like our conversation through a video call, like this is all achieved through transformers, or at least transformers enable like even better accuracy for those use cases. That's been a trend over the past 9 months. And we've introduced many model architectures within the transformers libraries and checkpoints. So checkpoints is like the actual model file. I didn't answer your question previously.
I forgot.
So yeah, contributed to by the community. Computer vision is another super important use case. People don't realize, but when Tesla, the car, drives with autopilot, it's actually a transformer model underneath that interprets sort of the virtual space into to make the decision of like what the car should do next. And yeah, it's, you know, time series, recommender systems, chemistry, biology.
Wow.
You've seen AlphaFold, right?
Yeah.
And now reinforcement learning too. Like how do we create agents that are able to have the best possible actions towards a
Actually
goal.
surprised when you showed it in the UI. I've been starting to dabble into reinforcement learning myself, and now I am gonna have to check out what you have in Hugging Face there, because I did not know that it was applied there. So
we actually just I think this week or last week released a really cool course about reinforcement learning. So if you're into video games and you want to train great character behaviors and stuff, we have some great resources to do that. I wanted to go back to our little query earlier for DALL-E Mini transformers in the sky.
Showed.
So yeah, if you see if you recognize this sort of mosaic of 9 uncanny images of things that seem plucked out of a dream, then that probably comes from DALL-E Mini. So yeah, we're super excited to see people all across the board who've never really dived into machine learning sort of play around those concepts and try to understand and start to understand like how they can be applied in the real world. What are the use cases? What are the potential issues that could come from the technology? So yeah, that's why like doing things in the open and with the community is so important to
everybody. I think you touch a word there that I kind of wanted to come back to. You mentioned issues, and here at Arize, that we want to help solving those issues. That's where we come in. So what issues or what production problems, hiccups, what are you seeing in the industry that it's the major pain points, or the most common and pain points that you would actually, if I ask you, what would you say?
I'd say like 3 main themes come to mind. The first one, the first challenge is that you know, AI teams across the board are not yet too deeply familiar with transformers and how to train them and how to work with them. And that's why providing easily accessible resources and easy to use tools to make use of them is such an important tenet of our mission, and how we've been having a lot of impact across the world. And that's why we feel like our mission doesn't really stop there with like the tools and the off-the-shelf resources that we're making available. We're also investing a lot in education. So education through you know, our book, the Transformers book.
Excellent book, by the way.
Read it?
I have it. I've read it. I have 2 chapters left. I knew some of the material previously, but I gotta say it kind of took the bluff out. Like it just made everything extremely clear. So whoever is listening, buy the book. It's amazing. I love it. So I'm
sure Tom, Leandro, and Luis would love hearing that. And then another thing is the course, right? So we put a lot of effort into creating education content for data scientists and machine learning engineers who want to understand transfer learning and transformers soup to nuts. And we're also engaging with the education community. There is a worldwide ML education tour right now happening at Hugging Face, where we will provide resources to teachers so that they can have their class onboarded onto our platform and use free resources to teach machine learning, as well as engaging directly in classrooms with universities to educate the field on what we've been seeing. And so that's the first problem. I say there were three. Sorry if I'm taking too long.
No, go ahead. I forgot that you mentioned three. Go ahead.
Another important one, and you mentioned production earlier, is linked to what I was discussing before about efficiency. So transformers, those pre-trained models, they're massive models that have been trained upon a gigantic corpora of data using incredible amounts of computing resources. And the output of that is models that typically would not fit on commodity hardware, on the type of computers and servers that are used, to do traditional tech and databases. And so it's very important to us, and it's a big challenge for the industry today, to take the models that their data science team have been successful in creating through Hugging Face transformers into production solutions that really scale, right? I mentioned the Gmail autocomplete. I mentioned Google search. I could mention, the Facebook translation, automatic translation of posts from your friends, Tesla Autopilot. All of those services serve billions of predictions a day based on transformers models. And that's really, really hard to achieve. Even if you take the scale a couple notches down, it is a huge challenge for enterprises today to take those models created with Hugging Face transformers and then deploy them very efficiently. So that's a problem that we're addressing through our open source and through our commercial solutions. And then the third one, when I was talking about issues in the context of the model cards, I was showing you what I was really thinking about is the bias issues and the potential harm that can be created when misusing a model, or when a model is used without sort of human interaction. And so that's a topic where the problems have been sort of clearly documented over the past couple of years. And they're particularly challenging in the context of large language models. And they're very important to address. I think nobody really has like a full comprehensive solutions, but we know that in order to mitigate any of the potential harms that could arise from the use of the models, we need to look at things through the whole chain, starting with the data set. Where is the data being sourced? What is the quality of the data set respective to like metrics that are measuring specifically this potential risk, right? And then how do you then measure your model and the evolution of your model against those particular metrics? And I think that's one topic that you guys at Arize are super interested in through monitoring of models, right?
That's definitely what we're working on, trying to help serving and definitely troubleshooting and being aware of what the models are doing, why they're doing it, and just so the AI doesn't drive in blind. We don't want AI models in the world ruling our world around us completely blind. We really want to know what's happening and how to improve it. So yeah, that's definitely our main problem is like it is not, as you were pointing out, it's not an easy, not an easy problem with not a simple solution.
Yeah.
I want to sorry.
And just, yeah, I mean, to continue on that because it's important. So, you know, measuring the effects after the fact is an important part of the problem. But for us, like, we need every step of the way to be open to the community so that they can be probed, they can be made adversarial against, and so that the discussion around the use of the model, the discussion around the sourcing of the data is well documented, well understood, and thoroughly discussed. Today, there isn't really an appropriate regulatory framework to deal with those questions because we're sort of learning in real time how to deal with these things. But I think it's very important to do things in the open and collaboratively as much as possible. A good example of that is the Big Science workshop, right? You have 1,000 leading scientists from hundreds of organizations coming together to build 176 billion parameter large language model, doing everything in the open so that all of those questions are being asked and discussed prior to going in and creating the model. Yeah, you know, I talked about like Gmail and Tesla and Google, and like we all use AI every day. And so very soon, like those capabilities, you know, machine learning is becoming the default way of creating technology. And so when systems start to make these decisions for humans, that's when we need to be super careful, mindful of what the edge cases could be and what that means in terms of potential harm to people.
That's so I want to wrap up, but I think before I let I let you go, thank you for your time. I want to ask a question because you were mentioning this team. I didn't know what you just said, by the way. So you mentioned this team that got together and tried to create a machine learning model, like completely on the open for anybody to see. But how can somebody that it's maybe not in that stage of their career, when they're in these cutting edge teams, how do you see the community contributing? And even better, how would you like the community to contribute in the future? What would you be your best case scenario what the community does at any stage?
Yeah, so there are lots of different layers at which you can contribute. So at the very basic layer, as a user, as somebody who's exploring all these different models, you can actually contribute and affect change by using the new community features that Hugging Face built on top of the hub. I can show you that quickly if you want. It's the ability to create pull requests. So say, I would like to change this by making this change, sending that to the model author, saying like, hey, can you add a license provision to your model card? Can you add a section about possible risks with your model? Can you change this parameter, right? So you can actually affect change in a very accessible way, and you can participate into the conversation for the model. So if I go back to our little transformer DALL-E Mini there, so this app is hosted in a Spaces repository. And so for every single model, every single data set, every single space, there is a community tab where you can ask questions, you can request a change. So that's, I think, like the easiest way through which people can really contribute to the community. A deeper level is, so we're providing these easy to use tools. so that data scientists can easily go from a pre-trained model and some data and create a new model. So another way to contribute is that once you've fine-tuned, once you've created a new version of a model that does something a certain way, then you can contribute it back to the community by having it into a public repository in Hugging Face, as with those other 50,000 models that I've shown you. And then another level above that is our open source. So at Hugging Face, we're about 125 machine learning engineers and a few people like me. But really, we represent the contribution of over 1,000 open source contributors, right, who have contributed new change, new features, new model architectures into these transformers open source library that's being used across the world.
Well, perfect. Well, thank you so much. I really appreciate everything you said. I congratulate Hugging Face, you and the company for the amazing success. I'm a fan, so I'm not going to hide my bias. So I love it. So I congratulate you. I feel very happy and fortunate that you were here talking to me. And we'll be answering the questions that everybody had in the chat and, of course, in the Arize community. So thank you so much, everybody else, for coming. And thank you, Jeff. Thank you so much for coming, too.
Thank you so much, Kiko. Thanks, Arize team, for the invitation. Bye.